Welcome to Sundar's lecture. This is lecture number 3, and in this lecture we are going to see octal to binary conversion. See what are all the topics we have seen in the previous class. See, we have started with the conversion of radix to one radix to another radix, and we have gone for binary, basics of binary, what is 2 input system, 3 input system, and then we have gone for 4 input system and how we can represent the decimal number with 0 to 15 with a binary, octal, and then hexadecimal, right? We have seen this one in the previous class, and also we have gone for types of conversion involving binary, any radix to decimal, decimal to any radix, and we have taken first one, that is binary to octal, and in binary to octal we have taken the binary numbers and then we have converted that into the octal, right? Now the next one, we have taken another example, and this one is B. This is B, octal to binary. Octal to binary. So, for example, if you have an octal number like this, for example, let us we take 758. 758. This is an octal number, and you need to convert this into equivalent binary number. This is the question. This is the question now. The same principle, whatever we have followed here, it is a reverse principle, reverse process. That's all. So what you do now, same thing, you write 7 here, and then 5 here, and then 8 here. That's all. You just split this one, split this 7, 5, 8. You will straight away get the values. What is not 8? Oh, okay, fine. 8 will not come in the octal, right? I made a mistake. Let this be 6 now. Let this be 6. 8 will not come. Try to understand. No 8 will be in the octal numbers. Only 0 to 7. Only 0 to 7. No 8 will come. Try to understand, right? So this will be 6. Now, what is the equivalent to 6 in binary values? What is the equivalent 6? It is nothing but, you see here, I will go here. See here, 6. What is 6? This is octal. This is 6. It is 101. So don't put this 0. Anyhow, I will see here. That is why I am not seeing here. See, this is 6. What is this one? It is 110. 110. Put this one 11 here. It is 110. And what is 5? It is 101. You try to understand. You get the values from the previous table. And what is this one? 7. It is 111. That's all. We have converted. You write all the numbers. So the final answer, it is 756 at the base of 8 will be equivalent to 111, 101, 110 at the base of 2. That's all. We have converted. Okay. So this is the procedure. This is the procedure. Maybe this is the first question, and we will go for the second one too. We will take another example. We will take another example with a point. See, we have a value like 463.32 at the base of 8, and we need to find what is the equivalent of base 2. What we are doing here, actually we are converting the octal into binary. Same thing, whatever we have done here. This is 4, this is 6, this is 3, and there is a point. This is 3 and this is 2. And you have to split this one. As usual, you just split this one. Split this one. That's all. See here, what is 2 now? What is 2? 0, 0, 0 is 1, 0, 0, 0, 0, 0, 1, 0, 1, 0. You write this one. And then what is 3? It is 0, 1, 1. And there is a point. You put this point. And again 3. It is 0, 1, 1. And what is 6? See, 5 is 1, 0, 1. And 6 is 1, 1, 0. See, you have, that is why I have told you in the previous class, if I say 2, then you have to defaultly understand it is 0, 1, 0, and those kind of things you have to be very clear. You have to remember those kind of things, or you have to write the tabular column and you have to see the tabular column and then write here. It is a long process. By practice it will come. You don't worry. It will come to you. Then if it is 4, then it will be 1 1 0 0 1 0 0. Actually, we try to remember the values in binary. Like if it is 2, it is 10. If it is 4, it is 100. If it is 8, it will be 1000. Likewise, I always try to remember. Then if it is 4, it is 100. Then 5 will be 101. Then 10 will be 110. Like that I try to remember. Okay. So you also do the same thing. 2, it is 10. 4, it is 100. 8, it is 1000. Right. 16, it is 10,000. Like that. You people will get it, those kind of shortcuts by yourself, right? So now this is the final answer. So you can directly write 463.32 at the base of 8 will be is equal to, straight away you write all these values: 100 110 011 point 011 01. See, after point, this 0 is an invalid thing. You don't need to put this 0. Even if you put, it is not a wrong answer. This is the base 2. This is the base 2. That's all. We have converted. See, if you know what is the procedure to convert binary to octal, that same thing, same procedure you have to follow to convert the octal to binary. That's all, right? Now what we will do, we will go for the next one, C, that is binary to hexadecimal. Hexadecimal. See what we are doing now, conversion. See what we are doing now, we are converting the radix involving binary. Wherever you go in this particular topic, you see octal to binary, binary to octal, everything comes within the binary values. That is why I have named this conversion type as binary involving binary. Anyhow. See, if we are having an example like this, for example, number 1, let this be A C 0 1 5 at the base of 16, because this is hexadecimal number. You need to, sorry, I have made this one. Anyhow, we are converting binary, right? Binary. So binary, for example, you have 1 0 0 1 0 1 1 1 0 1 at the base of 2, you need to convert this into equivalent hexadecimal number. You need to convert this into equivalent hexadecimal number. What you do now? The same procedure. Procedure will be same. Try to understand. Procedure will be same. That is why this is a separate category. 1 0 0 1 0 1 1 1 0 1. That's all. Now, what you do, for example, if this is the hexadecimal to binary to hexadecimal, binary is 2, right? Binary, the base of binary is 2, and you need to equate it to the hexadecimal value, that is 16, right? 16. And how 2 becomes 16? How 2 becomes 16? If in power, what you need to do, you need to put 4, right? You need to put 4. 2 power 4 will give you what? 16, right? So what you do now, you just split this binary values into 4 numbers, 4 numbers, right? 1 2 3 4 from right hand side. Try to understand. Don't come from here. You have to come from here. 1 2 3 4, this one. 1 2 3 4, this one. And if you have only 2 values, you add 2 zeros before here. That's all. And what is this one now? 1101. You come here. See here, 1101. It is D. It is D. Try to understand. 1101. The equivalent hexadecimal value is D, right? So what you need to do now? You have to put D here. You have to put D here, right? And then 0101, you have to understand, this is actually 5. You see, if you go here, then also you can easily understand. 0 1 0 1. It is actually 5. It is actually 5. 5. And what is 0 0 1 0? 10. It is 3. It is 3. Right? So you go here. Anyhow, I will show you one time. Oh, 0 0 1 0. It is 2. Sorry, 2. I have made a mistake. I made a mistake. It is 2. Right? Right. Now this is the equivalent hexadecimal value. See, for this value, the equivalent hexadecimal is 25D at the base of 16. And actually, this 25D, it is equivalent to the binary value. Try to understand, right? Now, if you have point values, maybe we will take another example number 2, so that you can easily understand. You have a value like this 1 0 0 1 1 0 1 0 1 point 1 0 1 0 1 at the base of 2, and you need to convert this into at the base of 16. Maybe you are converting binary value to hexadecimal value, right? You know the procedure. Same thing. You put 1 0 0 1 1 0 1 0 1 point 1 0 1 0 1, and you need to split it down from here. If you have point like this, then what you need to do, you have to start from here. 1 2 3 4, the first cut comes here. 1 2 3 4, the second cut comes here. And if you have only one value, what you need to do, put 0 0 0, 3 zeros, and you have to go from here. 1 2 3 4, you have to cut here. Then you have already here, right? So if you have only one here, you put 1 2 3 zeros. You have to make it, because even if you put zeros here, it doesn't matter. The value, it is an invalid zero, right? This is an invalid zero. So for our understanding, we are just putting this one. If you know 1, then you can straight away write all the values, right? So this is the procedure. And now 0 1 0 1, what is this one? Actually this is 5. And 0 1 1 1, actually it is 3. And 0 0 0 1, actually it is 1. And what is 1 0 1 0? 1 0 1 0, it is actually what? A. This is A, and you put point here. And one double 1000, actually it is 8. Actually it is 8. And you just refer this one. You just refer this one, you will get this one, right? So the equivalent, the binary value will be 135.A8 at the base of 16. At the base of 16. So we have converted, right? We have converted the binary to hexadecimal. Now we will take the next one. What is this one? D. 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 It is the same thing. Hexadecimal to binary. Hexadecimal to binary conversion. See, actually the same procedure again. What you do now, for example, if you have a problem, if they have given you A531 at the base of 16, you need to convert this into equivalent binary value. See, if you are converting hexadecimal to binary, then what you do, same procedure. Procedure will be same. A, and then this is 5, and then this is 3, and then this is 1. Same thing, you have to split all these ones, right? Now what is this one? What is 1? Equivalent, the binary value will be 0 0 0 1. 0 0 0 1. And what is 3? What is 3? It is 0 0 1 1. And what is 5? It is 0 1 0 1. And what is A? It is 1 0 1 0. See, that is why I have already told you. See, if you directly see any hexadecimal value, you have to put that, put the binary directly, 4-digit binaries. That is why I have tabulated the this one we have tabulated, right? This is very important, very important. You have to be very careful, right? Now, for example, now you have we have completed. What is the equivalent? A531 at the base of 16 will be is equal to 1010 and 0101 0011 this value 0001 at the base of 2. That's all. This is the final answer. This is the final answer. And we will take another one because we have to take it for a point one so that you can understand. For example, you have for example, you have AC 5.3B 3b at the base of 16, you need to convert this into equivalent binary value. Same thing, follow the same thing. This is A, this is C, this is 5 and there is a point here. This is 3 and this will be B, right? So you just split this one, split it out, point is there, no problem, and then this one will come, this one will come, right? Now you have to write the values. So 5, what is 5? So it is 0 1 0 1, and what is C here? See, 1010 will be A. 10. See, I'm just explaining you how to remember the values straight away. A will be 1010. You know, right? A will be 1010 and B will be what? 1011. That is B. Straight away you can write, right? 11. And then it will be C will be 1100, 100. After 11 you will have 100, right? So you remember A, that is 1010, and then you can easily put the B value will be 1011. After 11 it will be 100, so it will be 1100. So C will be what? 1100. And what is A now? It is very easy, 1010, and there is a point here. 3 will be 0011. That's all. And what is B? B will be what? 1011. That's all. So now you can write the final answer for AC 5.3B at the base of 16 will be is equal to, you have to take all these values, 1010, and then this will be 1100, 0101, 0.0011, 1011. That's all. At the base of 2. That's all. We have converted the this hexadecimal to binary. Right. Next one, what we will do now, this is E. Next one, octal to hexadecimal. Octal to hexadecimal. See here, what we have done before this particular topic, we have taken hexadecimal to binary. So hexadecimal equivalent, so we have seen here. What is this one? 2 power 4, which is equal to 16. So we have splitted the binary values by 4. And then even if you are going for binary to octal, and we have seen that octal is 8, so binary base is 2. So 8 will come by putting this 3, power 3, so that we have splitted the binary values into 3. It is very simple thing. So we have did that. Now my question, what is this one? What is the base of this octal now? It is 8. And then what is the base of this hexadecimal? It is 6. How you can make this 8 power something to become 16? Not at all possible. 8 power 1 it is 8. 8 power 2 it will be 64. So the point is, you cannot make this 8 straight away into 16 by putting any powers. So the procedure will be also a different one now. So how will you convert this octal value into an hexadecimal value? What is the procedure? And now that is very important here. What you do, you can convert octal to binary. That is possible, right? That is possible. We know how to convert binary to octal. That is what we have already seen. And from binary, you can convert this into hexadecimal. Try to understand. Try to understand very clearly. Can you understand? You straight away you cannot make the octal value into hexadecimal value. Not possible. So what you do? Convert this octal into binary and then binary to hexadecimal. That is why I have mentioned that this particular topic, named this particular topic as involving binary. You cannot convert without the binary values. All the conversions will comes under or will take part the presence of binary. right? So now we will do that, right? For example, if you have a problem like this, for example, 6, 5, 2 at the base of 8, you need to convert this into equivalent hexadecimal value. Equivalent hexadecimal value. So what you do now? You know the procedure, right? Again, the procedure is same. Try to understand. Procedure is same. Procedure is same. This is 6, this is 5, and then this is 2. You know, right? Now what you do? You have to split this one. Always we will do this. So you have to convert this octal to binary now. What is the procedure of converting octal to binary? You have to write three digits, three digits. Try to understand. That is very important here. So it will be 0, 1, 0. That is 2. And what is the value of 5? It is 1, 0, 1. You are converting to binary from octal. You have to be very careful. You are converting octal to binary, not binary to octal. It is octal to binary. So you have to write 3 digits only, 3 digits, because this is an octal number and you are converting that into binary. Be very careful here. So what is this one now? If this is 101, then it will be what? 110, right? This will be 110. So now this is the equivalent binary value. What is this one? 110, 101, 010. Now you got the equivalent binary value, right? Now this binary value can be easily converted into what? The hexadecimal value. So what you need to do here? Simple. You just write these values 1, 1, 0, 1, 0, 1, 0, 1. I'm writing correctly. 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0. Now, if you are converting binary to hexadecimal, what we have done here? See here, binary to hexadecimal. What we have done? Binary to hexadecimal, then you have to split by 4 digits. Split by 4 digits. Be very careful. Be very careful, right? So now 1, 2, 3, 4. This is the first thing. 1, 2, 3, 4. This is the next one. So you have to add 0, 0, 0. Maybe this value actually it is 0, 0, 0, 1 is there. So now you directly write the answers. So what is 1, 0, 1, 0? It is A. What is again 1010? Again it is A. What is 0001? Equivalent value of hexadecimal? It is 1. It is 1, right? So now we have got the answers. We have got the answers. Now this is the 1A at the base of 16. So what is the actual thing? 6, 5, 2 at the base of 8 will be equivalent to 1A at the base of 16. This is the procedure, right? What we need to do, we need to convert octal to binary, and then that binary should be converted into hexadecimal. There is no straight procedure to convert octal to hexadecimal. That is the whole idea. You have to be very careful. And for example, if you have any point values like this, we will take another example. Example number 2, 632.31 at the base of 8, and you need to convert this into equivalent hexadecimal value. And what you need to do, you put 6 here, 3 here, 2 here, point will be there, 3 will be there, 1 will be there, and you need to just split these values. I will go fast now because we have trained a lot, right? So what is 1? You are converting. See here again, you need to convert binary to octal to binary, and then that binary to hexadecimal. That is the procedure. So what you do now, you for this one you have to put 001, and for this 3 you have to put 011. This is point, and this is 010, and this is again 011, and 5 is 101, so it will be 110. So we have converted, right? Now what is the value? It is 110. This value will be 011, and this value will be 010, and there is a point here, you put point, and this value will be 011, and this value will be 001. Now this is the binary value. and this binary value has to convert it into what? Hexadecimal. So what you need to do? You have to split it by four digits. So from here, see here, this point should be very careful. You have to be very careful, right? So from here, 1, 2, 3, 4. You have to split this one. 1, 2, 3, 4. You have to split this one, and you know, right? This is 0, 0, 0, 1. You have to know. 1, 2, 3, 4. You have to split this one. See here, 0, 0, 1. You have to put another double zero here, so that it will be 4 values. So that it will be 4. And now you can straight away write what is 1, 0, 1, 0. What is 1, 0, 1, 0? It is A. It is A. 1, 0, 1, 0. And 1000 is 8. 1001 will be what? 9. Straight away. What is 0, 0, 0, 1? It is 1. And there is a point here. And what is 0, 1, 1, 0? 1, 0, 1, it is 5. 1, 1, 0, then it will be 6. And then 100. 100 will be 4. 100 will be 4. So this is the final answer. So what is the actual thing? 632.31 at the base of 8 will be is equal to 19a.64 at the base of 16. This is the final answer. This is the final answer. And now the same procedure will come. Same procedure. What we have done, octal to hexadecimal, and if you are going for F, that is the next one, hexadecimal to octal. Again, same thing. You cannot directly convert the hexadecimal into octal. So what you do now, you convert this hexadecimal to binary. That you know the procedure. And from this binary, you convert this into octal. This is the whole idea. So we will take an example. Hexadecimal value AC2 for an example. This is 16, and you need to convert this into equivalent octal number. What you do? Same thing. A, this is C, and this is 2, and you need to write these values. Huh? Try to understand. See here, you are converting hexadecimal to binary, so you have to write 4 digits. So students will make mistake here. Don't confuse yourself with the 3 digits or 4 digits. If you are converting to octal, then you have to go for 3. If you are converting to if you are converting from octal, 3 digit you have to use. If you are converting from hexadecimal, then you have to use 4 digits, right? Be very careful. And this value will be 0, 0, 1, 0. C. What is C? So you know this one, 1, 0, 1, 0. And B will be 1, 0, 1, 1. And C will be 1, 1, 0, 0. Try to understand. 1, 1, 0, 0. So now we have done, right? So what you do? You just write this one, 1, 0, 1, 0, 1, 1, 0, 0, 0, 0, 1, 0. This is actually binary number, and you need to convert this into octal. What you need to do? If you need to convert this into octal, then you have to split it by 3 values, because octal comes here. So 1, 2, 3, you put a line here. 1, 2, 3, you put a line here. 1, 2, 3, you put a line here, and you straight away have 3 values here. So no problem. So you just straight away write this value, 1, 0, 1, 0, it will be 2, and 0, 0, 0, it is 0, 0, 1, 1, it is 3, and 1, 0, 1, it is 5. So what is the actual answer? AC2 at the base of 16 will be equivalent to 53,202 at the base of 8. This is the final answer. And I will give you one question. You do it by yourself. I will explain you this one in the next class. 0. If you have any A, C, B point C1 at the base of 16 should be converted into an equivalent octal. This is a homework to you. You just do this one. We will see in the next class. See what are all the topics we have seen today. We have started with octal to binary conversion. What you need to do for octal value, you take this octal value, split the octal values and put the equivalent binary values, three digits, because you are converting octal. Octal means it will be three digits, because why that is coming, 2 power 3 will be is equal to 8. So you have to split it by three digits, and we have taken another example with the point values and we have converted. And the next one we have gone for binary to hexadecimal, and in binary to hexadecimal you have to split the values by 4 because 2 power 4 will be 16 here. So you have to take 4 digits, and we have gone for the point values, and then we have gone for hexadecimal to binary conversion, same procedure, reverse procedure, and then we have taken it to octal to hexadecimal. Octal to hexadecimal, you have to convert that octal to binary, binary to hexadecimal, and also hexadecimal to octal, then you have to convert this into binary, binary to octal, right? We will see in the next class.